So guys, in this video we are going to see the measurement of electrode potential. What's that? Measurement of electrode potential. Of course, from the previous video we have come across various definitions and the concepts. Yes. And from those definitions you have also come to know what do you mean by an electrode potential. So in simple words, if I had to explain once again what do you mean by electrode potential, Andre, of course it is the potential difference which is developed between the electrode and the electrolyte. Alva? Once again what I am saying, electrode potential andre enanta artha, whatever the potential difference which is existing between that of your electrode and an electrolyte. But of course, when I was explaining the electrode potential, I have given you a simple diagram by taking a beaker, yes, and dipping a respective electrode in its respective electrolyte solution. For example, if I am taking zinc rod, this is a zinc rod, and this is your zinc sulfate. Of course, whatever the electrode difference, whatever the potential difference will be existing between this electrode and the electrolyte, that itself is called as what? Electrode potential. But of course, this was a theoretical part. But how to measure it? I am saying, you are getting my point. How will you measure it? Because in this whole setup, I have never used a voltmeter or a galvanometer or any such instruments which can give me the value of those electrode potential. Yes or no? Are you getting my point? Even the diagram alna nimge ಏನು ಅರ್ಥ ಮಾಡಿಸಿದೆ ಅಂದ್ರೆ electrode potential ಅಂದ್ರೆ ಏನು ಅಂತ ಅರ್ಥ ಮಾಡಿಸಿದೆ. ಆದರೆ when the question arises, yes to electrode potential, what is the quantity of your electrode potential? How will you measure it? Because in this setup, I have never used any voltmeter which will be giving you the value of the electrode potential. So of course a question arises within us, that how will you measure that electrode potential? So that concept will be dealt over here. But remember guys, whenever we are measuring the electrode potential, one important thing you have to remember. What is that? Electrode potential is a relative quantity. What it is? Electrode potential is a relative quantity and it is not an absolute quantity. That means what? Relative means we have to compare it with something else. Hello, for example, when you are going with the physics, relative velocity. How we are calculating the relative velocity? You are comparing the velocity with some other moving object. Yes or no? The same scenario over here. What I am saying, electrode potential is not an absolute tendency. It is a relative tendency. That means if you want to calculate the value of an electrode potential, you have to measure it with respect to some another thing. You have to compare it with another electrode potential. Very much important. You have to remember this. But how will you measure it? Here comes an important part which is called as SHE. What is it called as? SHE, which means standard hydrogen electrode. Standard hydrogen electrode. Why is it so important? Because as I have mentioned, your electrode potential is a relative quantity. So the relative which you are going to measure, keeping one aspect as a common, and that common electrode we are going to choose will be your standard hydrogen electrode. So first of all, we'll get to know what do you mean by the standard hydrogen electrode by through its construction, what does it contain, and then we will see by using this standard hydrogen electrode, how will you measure the electrode potential. Okay. So basically, standard hydrogen electrode, it's a reference electrode antanu ಹೇಳ್ತೀವಿ ನಾವು. Okay, reference electrode. Give the name of the reference electrode anta ಕೇಳಿದ್ರೆ, it could be a standard hydrogen electrode, or sometimes in some of the books they also call it as a normal hydrogen electrode. Normal hydrogen electrode. So which is having, can give the abbreviation as a NHE. Normal hydrogen electrode. So first of all, let us check out its construction. How does it look like? So basically, first I will write its figure. So that then I can give you the clear-cut explanation. Yes, so somewhat it will be in this way. Yeah, and over here in the inside, this is very much important. Inside there will be a wire. and this wire is gone for an external connection, and through this part you are going to supply your hydrogen gas, and here we are keeping a 1 molar of a H plus solution. Yes. Okay, now when you see this setup, of course this overall will be a 1 molar H plus solution. So basically this is we can say as a construction. Okay, the figure looks like of your normal hydrogen electrode. A standard hydrogen electrode will be looking like this. So first of all we will see what are its content. So basically when you are seeing this a normal hydrogen electrode or a standard hydrogen electrode, first and the foremost thing, there will be a platinum wire. What it is? A platinum wire. This part is there. This is your platinum wire. So here is a platinum wire. Yes. Which is once again coated with a platinum called as a platinum black. This platinum wire ಗೆ ಇನ್ನೊಂದ್ಸರಿ ಒಂದು ಕೋಟ್ ಮಾಡಿರ್ತೀವಿ, ಅದು ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, platinum black. So this platinum wire is once again sealed in a glass tube. So whatever the outer part you're seeing, this one, okay, like a hot dog it is looking like. It's a sealed glass tube. Inside that sealed glass tube you will be having your platinum wire. So overall at the end, this part, it contains the end part of your platinum wire. Once again it consists of a platinum foil. This is your platinum foil. So first of all, in the standard hydrogen electrode you are having a platinum wire which is once again coated with a platinum black, and overall that platinum wire is first of all sealed in a glass tube, and at the end of that glass tube we are having one of platinum foil. So overall that foil is dipped in a 1 molar aqueous solution containing acidic solution. Okay, it's a 1 molar acidic solution. So overall that platinum foil is dipped in a 1 molar acidic solution, and through this opening we are going to bubble our hydrogen gas. Through this opening what we are doing, we are going to bubble the pure hydrogen gas. Of course the name here we are indicating as a standard hydrogen electrode, so of course unity is maintained, not an issue, and we are carrying out this experiment overall at the temperature range of 298 Kelvin. 298 Kelvin. So as I have said, basically this electrode is used to measure the electrode potential. Alva. So electrode potential na measure madbekondre, we know that whenever we consider a cell, there will be two half cells, in which one will be occurring a oxidation, another will be happening a reduction. Of course you can choose any of the electrode. For example, if you are choosing zinc electrode, in the Daniell cell we have seen that it is undergoing oxidation. So another part enagirbeko, whatever the cell you are going to choose, it will be undergoing reduction. Similarly, when you choose copper will be undergoing reduction. The another half cell should undergo what? Oxidation. Since in order to measure this electrode potential within a cell, we have to constitute a cell alva. Cell made naven madbeku iga electrode potential na calculate madbeku. So aa ondu cell na neevu ಮಾಡ್ತಿದ್ದೀರಾ ಅಂದ್ರೆ ಅರ್ಥ ಏನು? This standard hydrogen electrode should have the capacity to act both. Alva? If whatever the electrode you have chosen, if it is acting as an oxidation, your SHE should act as what then? Reduction. Similarly, if your chosen electrode is acting as a reduction, it is undergoing reduction, your SHE should act as what? Oxidation. So therefore, your standard hydrogen electrode acts as both anode as well as that of your cathode. ಏನಂತ ಹೇಳ್ತಾರೆ, ಈ SHE ಏನುಂಟಲ್ಲ, it can act both as an anode and a cathode. So when it acts as an anode, what does it say? When it acts as an anode, how the reaction will be? Anode ಅಂದ್ರೆ ಏನು? OA, oxidation ಆಗಬೇಕು. ಅಂದ್ರೆ H2 gas ಇದ್ದಿದ್ದು, it should give you as what? 2H plus in aqueous, plus it has to lose 2 electrons. Alva? So whenever your SHE is acting as an anode, this will be the reaction. Similarly, when it acts as a cathode, how can the reaction goes? Vice versa, alva? That means 2H plus plus 2 electrons will be giving you as H2 gas. Yes or no? That is the reason this is called as what? Reference electrode. Clear cut agi nimage gottagutte when you are measuring the electrode potential. Just for a while you remember how your SHE looks like, what are the parts you have to know in SHE, and what are those anode and the cathode reaction. Are you getting my point? Why we are using this SHE? So as I have said, the electrode potential is what? Relative quantity. So if you want to measure an electrode potential of an electrode, you have to measure with something relative to it. So that relative or a reference electrode by what we are using, the standard hydrogen electrode. So the overall setup you have seen where it is containing a platinum wire, which is once again coated with a platinum black, which is sealed in a glass tube, and at the end you are having a platinum foil, which is dipped in a 1 molar acidic solution, okay, and which is maintained at a temperature of a 298 Kelvin. So here SHE can act as both as an anode as well as a cathode, depending upon what type of an electrode you are choosing to measure the electrode potential. So when it acts as an anode, what we know, anode means in anode it should undergo oxidation. So H2, by losing the 2 electrons, it will be giving you as what? 2H plus. So similarly, if it is acting as a cathode, that 2H plus will gain 2 electrons and it will be giving you the hydrogen gas. Certain important things, of course, we know that how to write its cell representation alva symbolical ಯಾವ ತರ ಬರಿಬಹುದು instead of writing again and again this setup. ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಇದನ್ನ ನೀವು ಫಿಗರ್ ನ ಡ್ರಾ ಮಾಡದೆ ಸೆಲ್ ಬರಿಬೇಕು. ಓಕೆ, ಫಿಗರ್ ನ ಕೂಡ ಡ್ರಾ ಮಾಡಬೇಕು, ಸೆಲ್ಲಿನ ರಿಪ್ರೆಸೆಂಟೇಷನ್ ಕೂಡ ಕೊಡಬೇಕು. So that is the reason I have given you the clear picture that how does your SHE look like. So if I write the SHE in a symbolical representation, of course, how can I write? It is having a platinum, which is a solid, comma, hydrogen, which is a gas. So E part, this part and this part will be acting as one. Next in barbeko single part, which means an interface, and the solution no H plus, which is 1 molar. So this is a symbolic representation of your SHE, standard hydrogen electrode. Getting my point? One more important point. Remember, as I have said, it's a relative tendency. Alva relative tendency andre idukku ಒಂದು potential ಇರಬೇಕು. ಯಾಕೆ ನಾವು SHE ನ ಯೂಸ್ ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ the potential of the, or we can say the standard electrode potential. The standard electrode potential of your hydrogen electrode, standard hydrogen electrode is 0 volt. Very much important. 1 mark question. ಏನ್ ಹೇಳ್ತಿದೀವಿ ನಾವು? The standard electrode potential of your SHE is how much? 0 volt. Standard. I am asking again and again. I am saying standard at 298 Kelvin, 1 bar pressure, keeping the solution as a 1 molar. Your SHE's voltage is how much? The potential difference is how much? 0 volt. Is that clear? So these are the important things one has to know, because the next aspect what we are going to check out, that is the measurement of the electrode potential, will be requiring this part. ಯಾಕೆ 0 volt ತಗೊಂಡಿದ್ದೀವಿ, what is the importance of taking the 0 volt, how much easy the reaction will be all will be understood in my later concept. So the first important thing I would like to deal with will be measurement of, or I can say the measure of electrode potential copper electrode. So first of all, let us check out how we can measure the electrode potential of the copper electrode. So of course guys, in your textbook, they have given you directly this figure. First of all, I write that figure. Yen ಹೇಳ್ತಾರೆ ಅಂದ್ರೆ, so here you will be having the SHE, and over here you will be having like this sealed glass tube, and here you will be having your platinum wire. And that platinum wire will be connected to a voltmeter. Yes. So from here it is going to another tumbler where you are having your copper electrode, which is dipped in a 1 molar copper sulfate solution. Of course, external circuit na ಮಾಡಿದೀವಿ, internal circuit ಮರಿಬಾರ್ದು. There is a salt bridge. So like this they have shown you, and directly they have said that this is your anode, this is your cathode. Of course, they have given us the explanation also. What is that? Electron is flowing from SHE to copper electrode. But you think, guys, now you don't think as a student. Now you don't think yourself as a student. Think that you are a scientist now. Okay, and you are the first person who is going to determine the electrode potential, standard electrode potential of the copper electrode. Okay, what I am saying, don't think now, you just assume yourself as a scientist and think that you are conducting this experiment for the first time. You have no data, nothing, just you know that how to construct a cell, and we know that we are given with an SHE which is having a 0 volt, and I have to measure the standard electrode potential of the copper electrode. Okay, now my question is to you, is there a possibility to know which electrode will be acting as a cathode and which electrode will be acting as an anode before conducting the experiment. Are you getting my point? Experiment ಮಾಡಕ್ಕಿಂತ ಮೊದಲೇ can I say which SHE ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ SHE ಆನೋಡಾಗಿ ಆಕ್ಟ್ ಆಗುತ್ತೋ ಕ್ಯಾಥೋಡಾಗಿ ಆಕ್ಟ್ ಆಗುತ್ತೋ ಅಥವಾ ಕಾಪರ್ ಆನೋಡಾಗಿ ಆಕ್ಟ್ ಆಗುತ್ತೋ ಕ್ಯಾಥೋಡಾಗಿ ಆಕ್ಟ್ ಆಗುತ್ತೋ ಅಂತ ನಾ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಕ್ಕಿಂತ ಮತ್ತೆ ಹೇಳಕ್ಕಾಗುತ್ತಾ is my question mark. Are you able to say before conducting the experiment among SHE and your copper which can act as a cathode and anode? Of course not. Of course not. Then what will you do? What will you do? Assume that you are a scientist. What will you do? ಏನೋ ಒಂದು ರೀತಿಲಿ ನಾನು ಎರಡು ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡೇ ಮಾಡ್ತೀನಿ. ಒಂದು ಸೆಲ್ ನ ಸೆಟಪ್ ಮಾಡ್ತೀನಿ, ಕಾಪರ್ನ ಇಲ್ಲಿ ಇಟ್ಕೊಳ್ಳೋಣ, SHE ನ ಈ ಕಡೆ ಇಟ್ಕೊಳ್ಳೋಣ. ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ವೋಲ್ಟ್ ಮೀಟರ್ ಏನ್ ಮಾಡ್ತೀನಿ, ನಾನು ಗ್ಯಾಲ್ವನೋಮೀಟರ್ ನ ಹಾಕ್ತೀನಿ. ಸೊ ಗ್ಯಾಲ್ವನೋಮೀಟರ್ ಹಾಕಿದಾಗ ನಂಗೆ ಏನ್ ಗೊತ್ತಾಗುತ್ತೆ, ಅಫ್ಕೋರ್ಸ್ ಸೆಲ್ ನ ಕಾನ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಎಕ್ಸ್ಟರ್ನಲ್ ಸರ್ಕ್ಯೂಟ್ ಹಾಕ್ತೀನಿ, ಇಂಟರ್ನಲ್ ಸರ್ಕ್ಯೂಟ್ ಹಾಕ್ತೀನಿ. ಸೊ ನಂಗೆ ಗ್ಯಾಲ್ವನೋಮೀಟರ್ ಡಿಫ್ಲೆಕ್ಷನ್ ಇಂದ ಏನ್ ಗೊತ್ತಾಗುತ್ತೆ, ಎಲೆಕ್ಟ್ರಾನ್ ಫ್ಲೋ ಎಲ್ಲಿಂದ ಎಲ್ಲಿಗೆ ಹೋಗ್ತಾ ಉಂಟು ಅಂತ ಗೊತ್ತಾಗುತ್ತೆ. ಆರ್ ಯು ಗೆಟಿಂಗ್ ಮೈ ಪಾಯಿಂಟ್? ವೈ ಐ ಆಮ್ ಸೇಯಿಂಗ್ ದಿಸ್ ಬಿಕಾಸ್ ನೋ ನೀಡ್ ಟು ಬೈ ಹಾರ್ಟ್. ಯಾಕೆ SHE ಇಲ್ಲೇ ಬಂತು, ಯಾಕೆ ಕಾಪರ್ ನ ಇಲ್ಲೇ ಬರೆದ್ರು ಅದನ್ನ ನಿಮಗೆ ಕನ್ಫ್ಯೂಷನ್ ಇರಬಾರ್ದು ಅಂದ್ರೆ ಒಂದು ಎಕ್ಸ್ಟ್ರಾ ಒಂದು ಹಿಂಟ್ ನ ಕೊಡ್ತಿದ್ದೀನಿ. ನಿಮ್ಮನ್ನ ನೀವು ಸೈಂಟಿಸ್ಟ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಏನ್ ಮಾಡ್ತೀರಾ, ಈ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ನ ನೀವೇ ಮಾಡ್ತೀರಾ. ಸೆಲ್ ಅಂತ ಮಾಡಿದಾಗ ಹೆಂಗೆ ಇಟ್ರು ಕೂಡ ಯಾವುದೋ ಒಂದ್ ಕಡೆಯಿಂದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಮೂವ್ ಆಗ್ಲೇಬೇಕು ಅಲ್ವಾ. ನೀವು ಸರ್ಕ್ಯೂಟ್ ನ ಜಾಯಿನ್ ಮಾಡ್ತಿದ್ದೀರಾ ಅಂದಾಗ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಮೂವ್ ಆಗ್ಲೇಬೇಕು. ಆ ಸರ್ಕ್ಯೂಟ್ ಮಧ್ಯೆ ಏನ್ ಮಾಡ್ತೀನಿ, ನಾನು ಗ್ಯಾಲ್ವನೋಮೀಟರ್ ನ ಅಟ್ಯಾಚ್ ಮಾಡ್ತೀನಿ. ಸೊ ಗ್ಯಾಲ್ವನೋಮೀಟರ್ ಡಿಫ್ಲೆಕ್ಷನ್ ಇಂದ ನಂಗೆ ಏನ್ ಗೊತ್ತಾಗುತ್ತೆ, ಯಾವ ಕಡೆ ಎಲೆಕ್ಟ್ರಾನ್ ಫ್ಲೋ ಆಗ್ತಾ ಉಂಟು ಅನ್ನೋದು ಗೊತ್ತಾಗುತ್ತೆ ಅಲ್ವಾ. ಸೊ ಎಲೆಕ್ಟ್ರಾನ್ ಯಾವ ಕಡೆ ಫ್ಲೋ ಆಗ್ತಾ ಉಂಟು ಅಂದ್ರೆ ಅರ್ಥ ಏನು, ಯಾವ್ದು ಆನೋಡು ಯಾವ್ದು ಕ್ಯಾಥೋಡ್ ಅಂತ ಗೊತ್ತಾಗುತ್ತೆ. ಎಸ್ ಆರ್ ನೋ? ಸೊ ದ ಸೇಮ್ ಸಿನಾರಿಯೋ ಇಸ್ ಟೇಕನ್ ಓವರ್ ಹಿಯರ್. First, the scientists have conducted the experiment and they came to know that, okay, SHE will be acting as an anode and that of your copper will be acting as a cathode. And according to the IUPAC, International Union of Applied Pure and Applied Chemistry, they have said that whenever you are doing the cell representation, okay, first should be written as an anode and then you should go with the cathode. ಅರ್ಥ ಆಗ್ತಾ ಉಂಟಾ? ಆ ರೀಸನ್ ಇಂದನೇ ಸಿನ್ಸ್ ಒನ್ಸ್ ಯು ಹ್ಯಾವ್ ಕಂಡಕ್ಟೆಡ್ ದಿ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಯಾವ ಸೈಂಟಿಸ್ಟ್ ಮಾಡಿದ್ನಲ್ಲ ಅವನಿಗೆ ಏನ್ ಗೊತ್ತಾಯ್ತು, ಈ ಒಂದು ಕಾಪರ್ ಜೊತೆ ನಾ ಸೆಲ್ ನ ಮಾಡಿದಾಗ SHE ಏನಾಗುತ್ತೆ, ಆನೋಡ್ ಹಂಗೆ ಆಕ್ಟ್ ಆಗುತ್ತೆ, ಕಾಪರ್ ಏನಾಗುತ್ತೆ, ಕ್ಯಾಥೋಡ್ ಹಂಗೆ ಆಕ್ಟ್ ಆಗುತ್ತೆ. ಸೊ IUPAC ಪ್ರಕಾರ ಏನ್ ಮಾಡ್ದ ಅವನು, ಆನೋಡ್ ನ ಲೆಫ್ಟ್ ಅಲ್ಲಿ ಇಟ್ಕೊಂಡ, ಕ್ಯಾಥೋಡ್ ನ ರೈಟ್ ಅಲ್ಲಿ ಇಟ್ಕೊಂಡ. ಆ ರೀಸನ್ ಇಂದನೇ ನಿಮ್ಮ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ ಕೂಡ ಈ ತರನೇ ಫಿಗರ್ ಕೊಟ್ಟಿರೋದು. ವೇರ್ ಯುವರ್ ಆನೋಡ್, ಎಲ್ಲಾ ಫಿಗರ್ ನೋಡಬಹುದು ನೀವು. ಆನೋಡ್ ಏನಾಗಿರುತ್ತೆ, ನಿಮ್ಮ ಲೆಫ್ಟ್ ಅಲ್ಲಿ ಇರುತ್ತೆ, ಕ್ಯಾಥೋಡ್ ನಿಮ್ಮ ರೈಟ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. ಕನ್ಫ್ಯೂಷನ್ ಇರಬಾರ್ದು. ಹೆಂಗ್ ಗೊತ್ತಾಯ್ತು ಅನ್ನೋದಕ್ಕೆ ಇದೇ ಸಾಕ್ಷಿ. ಏನಂತ, ಫಸ್ಟ್ ಯಾರ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಿದ್ರಲ್ಲ, ಫಸ್ಟ್ ದೇ ವಿಲ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಸರ್ಟನ್ ರಿಸಲ್ಟ್ಸ್. ಆ ರಿಸಲ್ಟ್ ಮೂಲಕದಿಂದ ನಮಗೆ ಫೈನಲ್ ಒಂದು ಡಯಾಗ್ರಾಮ್ ನ ಕೊಟ್ಟಿರ್ತಾರೆ. ಓಕೆ, ನಾವು ಕಮಿಂಗ್ ಟು ಪಾಯಿಂಟ್, that is how I am going to measure the electrode potential of the copper electrode. So of course what we have done, we have set up our cell. Okay, it is combined with your copper electrode has been combined with that of your SHE, where copper electrode is dipped in a 1 molar copper sulfate solution which constitutes a 1/2 cell, while an SHE is representing your another half cell. Yes, so in this scenario we are able to see that the electron is flowing from SHE to copper electrode. What I am saying, once again mark my words, in this experimental setup we are observed that electrons are flowing from standard hydrogen electrode to copper electrode. So which is giving us the hint that SHE is acting as an anode and that of your copper is acting as a cathode. So in this experiment I am getting the voltmeter ಏನು ತೋರಿಸ್ತಾ ಉಂಟು ಅಂದ್ರೆ, the voltmeter I am getting the reading as 0.34 volt. ಎಷ್ಟು ಕೊಡ್ತಾ ಉಂಟು, ಓವರ್ ಆಲ್ ಈ ಸೆಲ್, ಇಡೀ ಒಂದು ಸೆಲ್ ಅಲ್ಲಿ, ನಾ ಬರೀ ಇಷ್ಟು ಮಾತ್ರ ಹೇಳ್ತಲ್ಲ, ಇಡೀ ಸೆಲ್ ನ ಮಾಡಿದಾಗ ಈ ವೋಲ್ಟ್ ಮೀಟರ್ ಏನ್ ಹಾಕಿದೀನಲ್ಲ ಇದು ನಂಗೆ ಎಷ್ಟು ರೀಡಿಂಗ್ ಬರ್ತಾ ಉಂಟು, 0.34 volt ಅಲ್ವಾ. ಸೊ ಆಫ್ ಕೋರ್ಸ್ ಐ ವಿಲ್ ಶೋ ಯು ಎಲೆಕ್ಟ್ರಾನ್ ಫ್ಲೋ ಅಂಡ್ ದಿಸ್ ವಿಲ್ ಬಿ ಮೈ ಕರೆಂಟ್ ಫ್ಲೋ. ಕರೆಂಟ್ ವಿಲ್ ಬಿ ಇನ್ ಆಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ವಾ. ಸೊ ಓವರ್ ಆಲ್ ಈ ಸೆಟಪ್ ಮಾಡಿದಾಗ ನಂಗೆ ಏನ್ ಬರ್ತಾ ಉಂಟು, ದ ವೋಲ್ಟೇಜ್ ಐ ಆಮ್ ಗೆಟಿಂಗ್ ಆಸ್ 0.34 volt. So how can this cell be represented now? Of course we know how to write. First ಏನ್ ಮಾಡಬೇಕು, ನಿಮ್ದು ಆನೋಡ್ ಬರಬೇಕು. So PT bar H2 which is 1 bar atmospheric pressure I have maintained, single bar H plus, yes, which is 1 molar. Then I have used a salt bridge, so double bars, then Cu2 plus which I have also mentioned as a 1 molar, and then comes your Cu which is solid. So this is the overall cell representation of this above figure alva. So by this way we have come to know that we are getting the voltage of how much? 0.34 volt. But what do I require? I am requiring the standard electrode potential of my copper electrode. Copper ಗೆ ಎಷ್ಟುಂಟು ಅನ್ನೋದೇ ನಂಗೆ ಇಂಪಾರ್ಟೆಂಟ್ ಅಲ್ಲಿ ಬೇಕಿರೋದು. ಸೊ ನಾ ಯಾವ ಫಾರ್ಮುಲಾ ಹಾಕ್ಬೋದು? Yes, as we know we are having the cell potential value. Overall cell in potential always ಸಿಕ್ಕಿರೋದಿರೋ 0.34 volt is the overall cell potential. ಯಾಕಂದ್ರೆ ಎರಡು ಸೆಲ್ ನ ಸೇರಿಸಿ ನಂಗೆ ವೋಲ್ಟ್ ಮೀಟರ್ ನ ಅಟ್ಯಾಚ್ ಮಾಡಿದ್ದೆ, ಅದರಿಂದ ನಂಗೆ ಬರ್ತಾ ಇರೋದು. ಸೊ ಈಗ ಏನ್ ಮಾಡ್ತೀನಿ ನಾನು, ಆಸ್ ಐ ನೋ ಇ ಸೆಲ್ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ವಾಟ್? ಇ ರೈಟ್ ಮೈನಸ್ ಇ ಲೆಫ್ಟ್. ಇ ರೈಟ್ ಮೈನಸ್ ಇ ಲೆಫ್ಟ್. So E right means, okay, this is what? Cell potential. But I want what? Standard part. Gibbs energy ಅಂದ್ರೆ ಏನ್ ಬರಿತಿದ್ವಿ ನಾವು? G. Standard Gibbs energy ಅಂದ್ರೆ G naught. So ಇದನ್ನ ಯಾವ ತರ ಬರಿಬಹುದು? Since I require standard part, so E naught of this cell is equals to E naught right minus E naught left. Alva standard part. So of course ಈಗ right ಅಲ್ಲಿ ಏನುಂಟು? This is my right. So I am having here as copper sulfate, which I don't know how much it is, so I will take it as E naught Cu. E naught Cu ಅಂತ ತಗೋಣ. E naught left ಅಲ್ಲಿ ಏನುಂಟು? You are having your SHE ಅಲ್ವಾ? So E naught H2 and let be it as E naught cell. So I know that E naught of this cell I have got how much? 0.34 volt. Okay, so 0.34 I have got. I don't know about E naught Cu, but I know that the standard hydrogen electrodes voltage is how much? It is taken as 0 volt. The voltage or the potential, standard electrode potential of your SHE is how much? 0 volt. So minus 0. So E naught Cu, how much I am going to get? It is equals to 0.34 volt. Are you getting my point? So I have got the standard electrode potential of my copper electrode. So yeah, it is a fixed quantity. So standard idu fixed quantity. Whenever you have taken 1 molar copper sulfate dipped in your copper electrode dipped in a 1 molar copper sulfate solution, the standard electrode potential of your copper will be 0.34 volt. Very much important. Signs are very much important. Plus, ಯಾಕೆ sign important ಅಂತ ನಿಮಗೆ ಹೇಳ್ಕೊಡ್ತೀನಿ. So by this way we can easily calculate. You have able to see that we have calculated the standard electrode potential of your copper electrode. But in case if I have to measure now the standard electrode potential of zinc electrode, standard electrode potential of zinc electrode, you just notify, you pay no attention over here how I am writing the diagram now. Okay, so ಇಲ್ಲಿ ನಾ diagram ನೋಡಿದ್ರೆ ಹೆಂಗ್ ಬರುತ್ತೆ ಅಂದ್ರೆ it will be in this way. So here at the left part we have taken our zinc, which is dipped in 1 molar zinc sulfate solution, and at the right part I have took my SHE. Of course ಈಗ ಯಾಕೆ ನಾನು ಅಲ್ಲಿಂದ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದೆ ಅನ್ನೋದು ಈಗ ಅರ್ಥ ಆಗ್ತಾ ಉಂಟಾ? ಯಾಕಂದ್ರೆ ನಾವು ಎಲ್ಲಾ ಟೈಮು SHE ನಮ್ದು ಲೆಫ್ಟ್ ಅಲ್ಲೇ ಬರೋದಿಲ್ಲ. ವಿ ಆರ್ ಡೂಯಿಂಗ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಯಾರು ಫಸ್ಟ್ ಕಂಡಕ್ಟ್ ಮಾಡಿರ್ತಾರೆ ಅವರು ಫಸ್ಟ್ ಗ್ಯಾಲ್ವನೋಮೀಟರ್ ಡಿಫ್ಲೆಕ್ಷನ್ ನೋಡ್ಕೊಂತಾರೆ, ಎಲೆಕ್ಟ್ರಾನ್ ಇಲ್ಲಿಂದ ಎಲ್ಲಿಗೆ ಮೂವ್ ಆಗ್ತಾ ಉಂಟು. ಓಕೆ, ಕಾಪರ್ ಅಲ್ಲಿ ತಗೊಂಡಾಗ ಏನಾಯ್ತು, ಎಲೆಕ್ಟ್ರಾನ್ ವಾಸ್ ಮೂವಿಂಗ್ ಫ್ರಮ್ SHE ಟು ಕಾಪರ್. ಸೊ ದಟ್ ಇಸ್ ದ ರೀಸನ್ ಅಕಾರ್ಡಿಂಗ್ ಟು IUPAC ಸಿಸ್ಟಮ್ ಏನ್ ಮಾಡಿದ್ರು, ಆನೋಡ್ ನ ಆ ಕಡೆ ಇಟ್ಕೊಂಡ್ರು, ನಿಮ್ಮ ಲೆಫ್ಟ್ ಕಡೆಗೆ, ಕ್ಯಾಥೋಡ್ ನ ರೈಟ್ ಕಡೆಗೆ. ಇದನ್ನು ಮಾಡಿದ್ನಲ್ಲ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್, ಅವನೇನ್ ನೋಡ್ದ ಅಂದ್ರೆ ಎಲೆಕ್ಟ್ರಾನ್ ಇಸ್ ಫ್ಲೋಯಿಂಗ್ ಫ್ರಮ್ ದಟ್ ಆಫ್ ಯೋರ್ zinc to that of your SHE. So that means what? Zinc should act as an anode, SHE should act as a cathode. So that is the reason according to IUPAC he kept the anode at the left, cathode at the right. Are you able to understand? So you have to also notify these all things. According to your syllabus only 2 are there, but whenever you are conducting the experiment in your higher classes, this is the protocol one has to follow. First you will be seeing electron ಎಲ್ಲಿಂದ ಎಲ್ಲಿಗೆ ಮೂವ್ ಆಗ್ತಾ ಉಂಟು. ಓಕೆ, ಆ ಒಂದು ಮೂವ್ ಆಗಿ ಡೇಟಾ ಏನ್ ಸಿಗುತ್ತಲ್ಲ ಅಲ್ಲಿ ನಮ್ಗೊಂದು ಹಿಂಟ್ ಗೊತ್ತಾಗುತ್ತೆ, ಯಾವ್ದು ಆನೋಡ್ ಯಾವ್ದು ಕ್ಯಾಥೋಡ್. ಅಕಾರ್ಡಿಂಗ್ ಟು IUPAC ಏನ್ ಹೇಳ್ತಾನೆ ಅಂದ್ರೆ ಆನೋಡ್ ನ ಯಾವತ್ತೇ ಅದು ನಾವು ಲೆಫ್ಟ್ ಅಲ್ಲಿ ಇಡಬೇಕು, ಕ್ಯಾಥೋಡ್ ನ ರೈಟ್ ಅಲ್ಲಿ ಇಡಬೇಕು. ಸೊ ಅವಾಗ ನಮ್ಗೆ ಒಂದು ಸೆಲ್ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಸಿಗುತ್ತೆ. ಸೊ ದಿಸ್ ಇಸ್ ಮೈ ಎಲೆಕ್ಟ್ರಾನ್ ಫ್ಲೋ ಅಂಡ್ ದಿಸ್ ಇಸ್ ಮೈ ಕರೆಂಟ್ ಫ್ಲೋ, ಅಂಡ್ ಅಫ್ ಕೋರ್ಸ್ internally I have done the connection through a salt bridge. Yes. So as I have given the explanation for that of your copper, here also what we can do, Here actually the SHE has been combined with that of your zinc electrode, in which it is being dipped to a 1 molar zinc sulfate solution. Yes. So in this case we are getting the E naught of the cell is equals to 0.76 volt. How much we are getting? Overall cell potential I am getting as how much? 0.76 volt. And of course here what is happening? Zinc is acting as what? Acts as anode, and your SHE is acting as what? Cathode. Why is it so? Because electron is flowing from zinc to SHE. Electron is flowing from which one? Zinc to SHE. Very much important, guys. These are the points one sees whenever an examiner is looking for your answer. First of all, he sees your diagram. Then he sees, okay, which is acting as an anode, which is acting as a cathode. Why it is acting? Because the electron is flowing from zinc to SHE. Then he sees what is the value of your E naught of this cell? 0.76 volt. So these are the points. Of course, examiner ge ಒಂದು sheet ಕೊಟ್ಟಿರ್ತಾರೆ scheme, they will not write in lengthy answers. Issu ಆರೆಲ್ಲ ಇರೋದಿಲ್ಲ. Just they will be mentioning these highlighted points. ಈ points ಇದ್ರೆ marks ಕೊಡಿ ಅಂತ. If these points are not there, whatever, how much ever you have written the history, no worth to it. Is that clear? So these are some important points. Then comes the next important point, is cell representation. So ಯಾವ ತರ cell represent ಮಾಡಬಹುದು ಈಗ? Copper ಅಲ್ಲಿ ಏನಾಗಿತ್ತು? Since SHE was acting as an anode, we kept it at the left position. ಈಗ ಇಲ್ಲಿ ಯಾವುದು anode ಆಗಿ act ಆಗುತ್ತೆ? Zinc. So zinc ಏನಾಗುತ್ತೆ at the extreme end, which is solid, single bar, Zn2 plus, which is aqueous. Then ಏನಾಯ್ತು? ಇಷ್ಟು part ಆಯ್ತಲ್ವಾ? Now salt bridge, double bar. Then as usual you will be using which one now? So here will be your H plus, which is 1 molar, and then there will be a single bar, which will be your H2, 1 bar. Okay, in some books they put as a comma, in some books they will also put as a line, which will be having at the last as your platinum solid. Are you able to understand? So from at the extreme left you will be having your anode, at the extreme right you will be having your respective cathode. Is that clear? Very much important part. So now when I am doing my calculation part, that is I have to calculate the standard electrode potential. Of course I know that E cell, first of all we should write as E cell, don't write as E naught. E cell is equals to what? E right minus E left. Yes. So then I want the standard part. So therefore E naught cell is equals to E naught right minus E naught left. So which can be given as what? E naught cell is equals to E naught right ಅಲ್ಲಿ ಯಾವ್ದುಂಟು? Right means this part ಅಲ್ವಾ? SHE. So E naught of my H2 minus E naught of my zinc. And I know that E naught of H2, the standard electrode potential of my standard hydrogen electrode is 0. And I know that E naught cell I have obtained from the experiment as 0.76 volt. So 0.76 is equals to what? Minus of E naught Zn. So that implies now E naught Zn is equals to how much? Minus 0.76 volt. How much? Minus 0.76 volt. Very much important to remember these signs also. Signs are very much important. Why I am saying so? Because when you saw the electrode potential of a copper, standard electrode potential of the copper, it was plus 0.34 volt. Whereas when you are coming with respect to the standard electrode potential of the zinc, how much you are getting? Minus 0.76 volt. Is that clear? So remember, whenever you are calculating the values or the electrode potential through this formula, whatever you are going to get, they are the standard reduction potentials. Mark my words. They are what? Standard reduction potentials. ಅವತ್ತೇ ಹೇಳಿದೆ ನಾನು, ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಪೊಟೆನ್ಷಿಯಲ್ ನ ಐಯುಪ್ಯಾಕ್ ಪ್ರಕಾರ ಏನಂತ ಹೇಳ್ತೀವಿ ನಾವು? ಸ್ಟ್ಯಾಂಡರ್ಡ್ ರಿಡಕ್ಷನ್ ಪೊಟೆನ್ಷಿಯಲ್. ಬಿಕಾಸ್ ವಾಟ್ ಎವರ್ ದಿ ಫಾರ್ಮುಲಾ ವಿ ಹ್ಯಾವ್ ಡಿರೈವ್ಡ್ ದಟ್ E right minus E left, it is mainly applicable for your whenever the electrode loses the electron. Okay, though here what is happening, ಏನಾಗ್ತಾ ಉಂಟು? ಎಲೆಕ್ಟ್ರಾನ್ ಗೇನ್ ಆಗ್ಲಿ ಲಾಸ್ ಆಗ್ಲಿ ನಿಮ್ಮ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಅದು ಮ್ಯಾಟರ್ ಅಲ್ಲ. ನಮ್ಗೆ ಮ್ಯಾಟರ್ ಏನಿಲ್ಲಿ ಅಂದ್ರೆ ಆ ಫಾರ್ಮುಲಾ ಏನ್ ಯೂಸ್ ಮಾಡ್ತಿದೀವಲ್ಲ, ಅದು ಯಾವ ತರ ಡಿರೈವ್ ಮಾಡಿದೀವಿ ಅಂದ್ರೆ, ಇಟ್ ಶುಡ್ ಆಲ್ವೇಸ್ ಗಿವ್ ಯು ದಿ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ರಿಡಕ್ಷನ್ ಪೊಟೆನ್ಷಿಯಲ್ಸ್. ಸಿಂಪಲ್ ವರ್ಡ್ಸ್ ಅಲ್ಲಿ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ? ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಪೊಟೆನ್ಷಿಯಲ್. ಬಿಕಾಸ್ ಇನ್ ಐಯುಪ್ಯಾಕ್ ಸಿಸ್ಟಮ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಪೊಟೆನ್ಷಿಯಲ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಇಟ್ ಇಸ್ ಆಲ್ಸೋ ಕಾಲ್ಡ್ as ಸ್ಟ್ಯಾಂಡರ್ಡ್ reduction potential. So the standard reduction potential of your copper is how much? Plus 0.34 volt, whereas the standard reduction potential of your zinc is how much? Minus 0.76 volt. Very much important, guys, to remember this. Okay. Why is it important? You will come to know in your electrochemical series, which I am going to deal in my next video. What is the importance of this sign? How does to place these electrodes? What happens if it is having a higher positive sign or a higher positive value or a lower negative value? All those things will be solved in my next video, which is under the topic electrochemical series. So that is the reason I am saying these signs are very much important. But for today's video, you have to understand what is SHE, what does it contain, and through your help of your SHE, how you are going to measure the standard electrode potential, E0. Okay, standard electrode potential. So as I mentioned, whatever the values you have got, they are what? Standard reduction potentials. But in case if somebody asks you, okay, this is the standard reduction potential of your zinc, what will be the standard oxidation potential? What will be the standard oxidation potential of zinc and also of copper? If somebody asks you, what you are going to do? So zinc ಏನು ಬಂದಿರುತ್ತಲ್ವಾ ಅದರದ್ದು sign ನ change ಮಾಡಬೇಕಷ್ಟೇ. So standard oxidation potential of the zinc will be plus 0.76 volt, whereas that of your copper will be minus 0.34 volt. Getting my point? Standard reduction potential ಏನು ಬಂದಿರುತ್ತೆ ಅದರ sign ನ opposite ಮಾಡಿದ್ರೆ standard oxidation potential ಬರುತ್ತೆ. ಅದೇ ರೀತಿ ಯಾವುದೋ ಒಂದು ಮೆಷರ್ ಇಂದ ನೀವು ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಆಕ್ಸಿಡೇಷನ್ ಪೊಟೆನ್ಷಿಯಲ್ ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ದಿ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ರಿಡಕ್ಷನ್ ಪೊಟೆನ್ಷಿಯಲ್ ಕೇಳಿದ್ರೆ just you have to change their sign. Numbers remain as it is. Is that clear? Very much important. And I would suggest you in any problems they will be giving you the standard oxidation potential. You just change them to standard reduction potential itself, because overall electrochemistry is dealing with the standard reduction potential values itself. Even in the electrochemical series, we will be seeing the standard reduction potential. Only in order to confuse you in your competitive exams, there is a chance that they can give you the standard oxidation potential. So you have to read the question very clearly and understand yourself. Okay, this is the standard oxidation potential they have given to us. Let us first convert it to standard reduction potential, then see their sign, and then you can go with your further calculations. So I think, guys, you have come to know what do you mean by the standard hydrogen electrode, what is the importance of the standard hydrogen electrode, what is the standard hydrogen electrode standard electrode potential, that is your 0 volt. Then we also saw certain aspects or experimental aspects, that how will you measure the electrode potentials of your copper and that of your zinc. And do remember, whatever the formula E right minus E left you're going to put, and whatever the values you're going to get, they will be your standard reduction potentials. So in case somebody asks you the standard oxidation potential, what is the thing you have to do? You have to just change their sign. The numbers remains as it is. Now I would like to give you one aspect over here. I want to just say it. Of course, when I was dealing with my first concept of electrochemistry of a Daniell cell, I have said that in the Daniell cell, when you are maintaining the standard condition, you have got as how much? 1.1 volt. Yes, 1.1 volt. Of course, how did I get? Okay, this was what from the practical voltmeter na use ಮಾಡಿ sir. Voltmeter ನಿಮಗೆ 1.1 volt ಸಿಗುತ್ತೆ. Voltmeter 1.1 volt ಸಿಗ್ತಾ ಉಂಟು ಅಂದಾಗ ನನಗೆ ಥಿಯರಿ ಕೂಡ ಅದು ಸಿಗಬೇಕು ತಾನೆ. What I am saying, in theory also I should get this same, because then only we'll get to know that the theory and the practical both are same and they are also correct. So let us have a now look over that, because I have got the values of now which one? E0 of the copper also I have got, E0 of the zinc also I have got. So E0 of the copper, how much I have got? I have calculated over here a lot. That is how much? Plus 0.34 volt, and that of the zinc is minus 0.76. Okay, plus 0.34 volt and zinc is minus of 0.76 volt. So when I am considering the Daniell cell, of course there my zinc will be acting as what? Anode, and my copper will be acting as what? Cathode. Yes or no? So okay, so I know the formula that E0 of this cell 1.1 volt ಏನು ಸಿಕ್ಕಿರೋದಂಗೆ ಇದು E0. ಸೊ ಇದು ಬರುತ್ತೋ ಇಲ್ಲ ಅನ್ನೋದು ಚೆಕ್ ಮಾಡಬೇಕು. ಈ ಫಾರ್ಮುಲಾ ಸರಿ ಉಂಟೋ ತಪ್ಪು ಉಂಟೋ ಅನ್ನೋದು ಗೊತ್ತಾಗುತ್ತೆ. So E right minus E naught left. So E naught right mandre yav kade irado andre zinc copper alva. So when I am choosing in this way, so here was my zinc, here was my copper. So at the right part I am having my copper, at the left part I am having my zinc. So copper in this two I am having how much? Plus 0.34, minus is there. E naught of the less system, that is my zinc, minus of 0.76. So minus of minus 0.76. So that is equals to 0.34 plus 0.76 will be equals to how much? You can only calculate. We will be getting the value as the same equals to this much. That is 1.10 volt, or we can just take it as a 1.1 volt. Are you getting my point? So whatever in the practical we have got, it is resembling with that of your theoretical part also. So this formula is correct. Of course, it is not mentioned in your textbook. Just for our convenience and what we are understanding. ಯಾವತ್ತೇ ಒಂದು ಲೆಸನ್ ನಾವು ಓದ್ತಿದ್ದೀವಿ, ನಾವು ಕೂಡ ಏನು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ, ಯಾವ ತರ ಅದನ್ನು ಅಪ್ಲೈ ಮಾಡಬಹುದು ಅನ್ನೋದನ್ನ ನಾವು ಕಲಿಬೇಕು. So this is one type of an application. Of course, we come to know standard electrode potential. ಆ electrode potential ಡೇನಿಯಲ್ಸನ್ ಗೆ ಹಾಕಿ ನೋಡೋಣ ಅಲ್ವಾ. ಸೊ ಡೇನಿಯಲ್ಸನ್ ಹಾಕಿದಾಗ ಏನ್ ಬಂತು, ಏನ ನಮ್ಗೆ ಪ್ರಾಕ್ಟಿಕಲ್ ಅಲ್ಲಿ 1.1 ವೋಲ್ಟ್ ಸಿಕ್ಕಿತ್ತು, ಅದೇ ನಮ್ಗೆ ಥಿಯರಿಟಿಕಲ್ ಕೂಡ ಸಿಗ್ತಾ ಉಂಟು. Are you getting my point? Also, along with this video, I have also attached one experimental part of the Daniell cell itself, where you'll come to know that how it is giving you the reading of 1.1 volt. Have a look at it. Okay, very much important concepts, guys, because I think this electrochemistry's electrochemical series is one of the most important and also one of the interesting topic, because through those values you can easily judge which part or which metal can act as a better reducing agent, which metal can act as a better oxidizing agent. If you have been given with a series of metals and you have been asked that which will be a better reducing agent, looking through their standard electrode potential values, how can you measure, how can you identify them, all these aspects will be dealt in my next video. Till then, whatever we have learned, glance it. If there any doubt arises, you can please post your doubts in my WhatsApp group. Is that clear? So very much important concept. Whatever we have dealt today, try to understand it. Any doubt, anytime, please feel free to ask. Okay.
Determination of EMF of a cell. The device which produces electrical energy from a chemical reaction is called an electrochemical cell. The best example of an electrochemical cell is the Daniell cell, in which copper and zinc electrodes are immersed in a solution of copper sulfate and zinc sulfate respectively. The two half cells are connected through a salt bridge, which is an inverted U-tube filled with a saturated solution of an inert electrolyte containing agar-agar. Here, zinc acts as anode and copper acts as a cathode. At the anode, zinc undergoes oxidation to form zinc ions, which pass into the solution and electrons. If the two electrodes are connected using an external wire, the electrons produced by the oxidation of zinc travel through the wire and enter into the copper cathode, where they reduce the copper ions present in the solution and form copper atom, which are deposited at the cathode. The potential difference between the two electrodes is called cell potential or EMF of the cell. It is measured in volts. Our aim here is to study the variation of EMF in the zinc-copper electrochemical cell with the change in concentration of electrolytes at room temperature. Materials required: zinc sulfate solution, copper sulfate solution, zinc rod, copper rod, digital voltmeter, salt bridge and connecting wires. Procedure: take 1 molar copper sulfate solution in a clean beaker and 1 molar zinc sulfate solution in another beaker. Take a clean copper rod and dip it into the beaker containing 1 molar copper sulfate solution. Similarly, take a clean zinc rod and then dip it into another beaker containing 1 molar zinc sulfate solution. Take the salt bridge and connect the two solutions through the salt bridge. Now, take one connecting wire and using the wire, connect the copper rod with the positive terminal of the digital voltmeter. Copper electrode acts as the cathode. Similarly, Take the other connecting wire and connect zinc rod with the negative terminal of the voltmeter. Using the wire, zinc electrode acts as the anode. Now switch on the voltmeter. Note down the voltmeter reading. This value gives the EMF of the cell. Record the observation in a tabular column and repeat the experiment by taking different concentrations of zinc sulfate and copper sulfate solutions. From the observations, it is clear that EMF of a cell increases with the decrease in concentration of the electrolyte around anode and increases in the concentration of electrolyte around the cathode.